Hello guys, welcome to this beginner's guide to ArcGIS desktop tutorial. Through this tutorial, I aim to give you guys a very in-depth understanding of the capabilities of ArcGIS desktop if you're getting started as a beginner. Now, Esri's ArcGIS has been around for quite a long time, and even today, despite the competition it gets from so many other commercial and also open source GIS tools, it remains as one of the most widely used GIS softwares in so many different areas like the health sector, transportation and navigation, water resources engineering, geological sciences, you name it. So yeah, before we start looking into this program, let's just see what sort of topics we're going to cover during this tutorial. Now again, this is an introductory guide for beginners, but what's interesting is that I'm going to take you through these functionalities which we're going to discuss through practical applications. That means by the end of this course, you will know exactly what can be done using the available tools, and also how you can use those tools to actually get the work done that's relevant to you quickly and efficiently. I have divided this tutorial into 4 parts. To start off, I'll give you a bit of an overview of what ArcGIS Desktop is, and we'll discuss the different components of the interface. Then we will move on to discuss how we can use this software to work with vector data. Now on the screen you can see the type of subtopics we're going to discuss, things like types of vector data, how to do basic styling and geoprocessing tasks, and how to edit the attributes, and how to use the field calculator and the geometry calculator, and how to digitize things, and how to create new shape files, and how you can export those new vector files into different file formats. Now in the third part, I will be going over how we can use this software to work with raster data. Now we will be covering things like introduction to raster data, styling and visualizing, how we can use geoprocessing tools to work with raster data, for the purposes such as clipping, and how we can actually do a 3D visualization of a raster, discuss things like what is raster reclassification and how to get certain spatial statistics from raster data. Also, I'll be showing you how we can convert between rasters and vectors, and what could be those potential benefits of being able to convert between raster data and vector data. And in the fourth part, I'm going to explain to you guys how you can create a standard map using the data which we worked with to create a very meaningful map which you can, let's say, present to your clients, or even just do it for yourself for your own satisfaction. Now, as you saw, we are going to cover quite a bit of things here in this tutorial, and I will guarantee that this will be sufficient for you to have a general understanding of the capabilities of this software. And then of course, with that head start, you'll be able to easily discover a lot more on your own quite comfortably. Alright guys, so without further ado, let's go ahead and get started with the tutorial. ArcGIS Desktop is comprised of 4 main parts. We have ArcMap, ArcCatalog, ArcScene, and ArcGlobe. We can say that ArcMap is the primary application where we usually put most of our attention, because that's the program which actually lets you work with our GIS datasets to do things like use the geoprocessing tools, compile and edit the GIS datasets, automate certain workflows, create and let's say print maps, organize and manage your geodatabases, things like that. So it goes without saying that this is the piece of software which we'll be spending most of our time with during this tutorial. Now, ArcCatalog is a dedicated tool which we can use to organize and manage our GIS data. Now, if you're a Windows user, you can say that it's something like the Windows Explorer, but in this case, it's a part of the ArcGIS desktop application. Now, ArcGIS Catalog can help you to properly organize your GIS files and manage your geodatabases, search for certain contents, manage your GIS servers, things like that. So coming on to ArcScene. ArcScene is another component of ArcGIS Desktop which is primarily used for visualizing geospatial data in 3D. Now in here you can do things like create 3D feature data, use 3D analyst geoprocessing tools to edit or modify your 3D data, and visualize your 3D data and do things like draping images or vector data over surfaces, create 3D animations using your 3D data so that you can provide a much more interesting 3-dimensional presentation of your GIS data to your clients, things like that. So finally we come to the ArcGlobe application. Now ArcGlobe is another application under ArcGIS Desktop which allows you to weave your GIS data on a globe surface. It's quite useful in the sense that you can use your GIS data both in 2D and 3D and sort of weave them with a global perspective. Alright, now let's go back to ArcMap and we'll have a look at the user interface of ArcMap. Now over here you can see that I have opened up ArcMap, and the 2 different lines that you see over here on the top are actually the toolbars, different toolbars. Now we have the flexibility to actually move the toolbars around. If you move your mouse pointer on top of this thing that you can see actually something like a dotted line, you will see that your cursor changes, and you can just simply click on that particular toolbar and you can actually drag it around. And over here you can see actually the name of this toolbar is the standard toolbar, and we have another toolbar which is the tools toolbar. And of course, if you want to put them back in, you can simply move the toolbar to that designated place and it'll sort of fit in automatically, just like this. Now in the standard and the tools toolbar, you can see that we have a few buttons. Now we'll actually talk about these buttons as well. Before we do that, I would also like to talk about this table of contents that you see over here. Now this is actually something that we will always be using when we are using ArcMap, and this can be viewed as something like a panel. Now specifically about the table of contents, we will be using this primarily to visualize our layers. Now in GIS programs like ArcGIS, in which we get this ArcMap application, we're basically working in an environment where different geospatial information will be structured as different layers. And all of those different layers will be actually sort of get placed in this table of contents. And you can move that around just like this, as you can see over here. But usually I prefer to keep this on the left side. So what I would normally do is I bring my mouse pointer over here and it'll sort of automatically snap in to the correct place, just like this. And even if you go to Windows, you can see that you have the same thing over here. In case if you do not have this table of contents, whenever you happen to open ArcMap, you can simply go to Windows and you can actually enable the table of contents. And it'll open up as a different panel over here. And over here you actually see two more panels, which are the catalog and the search. Now one interesting thing is that even though we have the capability of opening our catalog as a separate application, we don't really have to do that, especially when we are working with ArcMap and when we quickly need to access our geospatial data. It's very convenient to actually have this option over here, which will open up our catalog itself as a separate panel, as you can see over here, which you can just move around according to your convenience, just like this. I'm going to snap it to the right side. We can use this Arc catalog to actually connect to our data. Now, for example, if I wanted to connect to a separate folder, let's say I keep my information in a specific folder in D drive. So by default, we won't be able to weave that particular folder. You can see even if I click on this drop down menu, we do not really have that. So what we need to do is we actually have to first create a connection. That's how ArcMap operates. Whenever we need to access a separate folder, we need to create a connection first. So the way to create a connection is actually by using this connect to folder button. And once you have that, you can see that I can actually very quickly navigate to the folder which I'm interested in. It's in this GeoDelta Labs folder, and it's actually the folder which corresponds to this particular tutorial, which is number 9, as you can see over here. So all you have to do in order to connect to a certain folder is simply select that folder over here and click OK. You can see that the folder which you connected to will appear right over here. And you just have to do this once. And after you have done it once, you can simply expand the contents of that folder simply by clicking on this plus sign. And right now you can see that I have two folders, these raster and shape files. And if I expand this, you can see that we have certain number of files actually inside this. So we are able to directly access these files without actually having to navigate to these individual files using the Windows Explorer, thanks to this inbuilt Arc catalog of ArcMap. We'll be using this quite frequently, so I'm not going to discuss much at this particular moment because we will definitely be using this inbuilt Arc catalog during the future steps of this tutorial. And in addition to this, I also would like to draw your attention to this search panel that we have over here. In fact, if you do not want to access this through Windows, you can simply click on this button of the standard toolbar. And I think you'll be able to recognize that this is the catalog button, which will open up this inbuilt Arc catalog. And similarly, you can see that we have a search panel as well. Now, personally, I very frequently use this search panel because I've been working with ArcGIS for quite some time, so I know exactly what I'm looking for. And that's precisely how this search panel can be of use to you guys. Now, if you're a beginner, then I suspect that you might not get much of a use from this search panel because you might not know exactly what to search, isn't it? When you gain a bit of experience and you get seasoned with different tools by using them quite frequently, for example, if I want to do an intersect operation, I know that there's a tool called intersect. Now, I can either go to this Arc toolbox and try to find where that intersect tool is, or what I would normally do nowadays is simply come over here and I just type intersect and just hit enter, and it'll sort of list down all the things which happens to sort of contain that word intersect. And from when I see this, I know exactly what to look for. So that's one of the benefits of actually having this search panel, especially when you're familiar with the different tools. But let's say as a beginner, what I would recommend to you guys, at least for some time, is to actually just explore this Arc toolbox, which you can see over here, which contains all the tools that are sort of embedded in this ArcMap program. And it contains hundreds of tools which will be actually quite useful for so many different geoprocessing tasks that we are going to perform. But of course, we're not going to make use of all the tools over here. We will be using only a handful of the tools. But of course, you can see that the tools actually pertain to different types of special operations. And again, if you're a beginner, it can be a bit overwhelming when you see this toolbox like this. Now, for example, I'll just show you guys a quick trick. I told you guys that I've been using this intersect tool directly from the search panel. Now, if you click on this green color line of text, you will see that it actually opens up the toolbox inside Arc Catalog. So you know that this intersect tool is located in Analysis Tools, Overlay, and Intersect. So if I go over here to Analysis Tools, Overlay, and from here you can see that I can access this intersect tool. So simply I can double click and the tool will open up just like this. Well, don't worry, we are not going to use this tool just yet, because I'm still talking about the interface in general, and we haven't actually dived into any geoprocessing operations yet. So that's a bit of a description about these different toolbars and panels that you can work with when you're working in ArcMap. Alright, now we'll go ahead and start working with some vector data. Now if you look over here, you can see that there's one folder called shapefiles. Now extra shapefiles are actually one type of vector data, but there are so many other different vector data types. But for this tutorial, we'll be mainly focusing on the type asterisk shapefile, which is actually one of the most commonly used type of GIS vector data. Now over here that I have different shapefiles called banks, natural water, region of interest 1, region of interest 2, river, study area, and you can see that the file itself is actually just a single file called .shp. Now this is actually the shapefile which we are interested in, but if I were to navigate to the same place through my Windows Explorer, yes, over here you can see that I have actually navigated to the same location, which is inside this shapefiles folder. But you can see that for banks over here, even though we see just one file, you can see over here actually that particular name has got 1, 2, 3, 4, 5, 6, 7 different files. And the same goes for natural water as well. As you can see over here, this asterisk shapefiles are actually not just one file. It's actually a collection of different files which serves a specific purpose. Now, for example, if you talk about this banks shapefile, you can see that we have one file called banks.prj. Well, this is the file which actually contains all the information about the projection. And this banks.dbf will actually contain all the information which corresponds to the attributes of that particular shapefile. So similarly, all of these files together actually forms the asterisk shapefile. Now that's something to keep in mind. And if you want to open one of these shapefiles from this Windows Explorer, it can be a bit confusing which file to sort of open, isn't it? And if you wanted to access this shapefile using some sort of a GIS tool like ArcGIS, and if you were to navigate to the place using Arc Catalog, it actually only shows you the file which is relevant to us, which is this .shp file. So for an example, if I wanted to open this region of interest shapefile, all I have to do is just drag it and drop it into your working interface. And now you can see I have something called my region of interest 1. Now you might be curious to know what is the region of interest 2. So all I'm going to do is just select this, drag it, and drop it over here. By the way guys, if you're following along and if you would like to do the same exact thing that I'm doing right now, I'll be passing you all of these data as well. You can download them quite easily from the link which I have given in the description. So make sure that if you're actually just getting started with ArcMap, or if you just want to replicate the same exercise which I'm doing over here, first make sure you download this set of data, and after that you can actually follow along without any problem. Alright, similarly, I have another shapefile called river over here. Now you can see that when I dragged and dropped this region of interest 1 and region of interest 2, both of these shapefiles are actually kind of polygons, as you can see quite clearly. And if you're using a mouse, you can use your scroll wheel to actually zoom in and zoom out, just like this. But let's drag this river shapefile and see how it looks. Yeah, now you can see that this river is actually not a polygon, but it's something like a polyline, but it's a line. Now this type of geospatial data is actually belonging to the type polyline. This region of interest, since we're covering a big spatial area, it's of type polygon. And over here, let's say we have another shapefile called banks. So what I'm going to do is I'm going to drag it and drop it over here. And now you can see that it's actually of a different type. It's not a polygon or a polyline either. Now this shapefile is actually of the type point. Alright, now if you look closely at these different files, you can see that the icon itself differs from one another. Now you can see that this natural water, region of interest 1, region of interest 2, study area, all of these actually having the same type of icon, which says that it's actually of the type polygon. But the river, you can see that it looks sort of a line, which indicates that it's actually of the type polyline. But the banks, you can see that it shows a couple of dots over here, which gives the idea even before you open the shapefile that it's actually of the type point. So that's actually something quite useful, especially when you're navigating using this Arc catalog. Alright, now let's say that if you wanted to access the specific information about each of these different attributes, all of those information can be quite easily accessed using something called an attributes table. If you happen to have multiple attributes, those information will be listed down in this so-called attributes table. Now, for example, when you have the dots over here, just because the name of the shapefile was banks, you sort of might have an idea that it might be the locations of these different banks, but right now we have zero information about each of these individual specific dot. For example, you don't know what each of these dots actually refer to, which bank or which location. And just like that, we have zero information right now. So if the provider of the shapefile has already embedded those information into this shapefile, you can simply access all those information simply by going over here to the layers panel and click on the corresponding layer which you would like to access. Right click over here and go to this attributes table. And keep in mind that all of these vector files, all of these H3 shapefiles will contain this attributes table. Having the data inside the attributes table or not is actually another thing, but every GIS vector file should have an attributes table, just like this, which you can simply open up and you can have a look at that from here. Especially when you're working with GIS data from different sources, this attributes table could be a bit messy, because when we get data from different sources, it's not always like properly organized, unless if you were to do it by yourself. And as GIS analysts, it's one of the most common tasks. Before using the GIS data for some useful purpose, we first have to clean it up in a way that the data can be actually used for some meaningful purpose. Now over here, these different rows that you see over here corresponds to different attributes. In this case, these different rows actually correspond to different points. Now you can see that when I highlight each of these rows, if you look over here, you can see that the corresponding point gets highlighted as well. So that's one way to select attributes. And let's say if you wanted to select multiple attributes, you can click your mouse button and drag it just like this, so that you can see that multiple attributes or multiple points in this case gets highlighted. And if you want to deselect all your selections, you can click on this button, which is this clear selection button. And let's have a look at the columns. We have something interesting over here. You can see that the shape, the type of the shape is actually a point. Now that's because this is of the type point, as I explained to you guys before. And when you create the shapefile, this column will be there no matter what. This particular column will be there because it indicates the type of your shapefile. And over here you can see very clearly each of these attributes are actually of the type point. And these other columns can actually vary depending on the source where you got your data from. Now, this shapefile actually I downloaded from OpenStreetMap, so this is how it looks. And over here you can see that we have things like the name of the bank over here, and we have the operator, and we have some information about whether that bank has an ATM or not. Most of the banks say yes, and there are a couple of banks which also say no over here. And over here there is one column called brand, brand wiki, brand WI1. I'm not sure what that refers to. Just like that, we actually have quite a bit of information. We have something like a street address, but it's not present for all the banks. And we have just one single phone number over here. And again, as I told you, the completeness of this information actually will depend on the source of the data which you acquired this data from. And now if I close this and open up this river shapefile, the attributes table of this river shapefile, you can see that very clearly it mentions the type of the shapefile, which is of polyline. And similarly, we get to see all those different types of columns. And what I'll be mostly interested in is actually this one, the name of this river. But you can see over here that we just have two rivers, but we happen to have quite a number of attributes. Now, I'm also curious as to why we have so many different attributes. You can see that the river name is actually it's either River Taff or River Eli, but we get to see different pieces of attributes just like this. Now, if you would like to actually do a bit of a sorting, because as you can see over here, the attributes have been mixed up between River Taff and River Eli, I'm going to just double click over here, and that'll sort of do a quick sort. And you can see that first, all the attributes which corresponds to river Eli appeared. What I'm going to do is I'm going to actually select only this first attribute and see whether something got highlighted or not. You can see that this middle part of the river got highlighted. And when I click on this one, you can see that this part of the river got highlighted. Similarly, just like that. And similarly, when I click on this river Tough, you can see that this part got highlighted. And this part got highlighted when I click on this one. So what if I select the entire set of attributes? Yeah, you can see that the entire polyline got highlighted. And when you look at this, you should get the idea that this is not just one single polyline, but it's actually a continuous set of different polyline pieces. That's why we have different pieces of attributes just like this. But somehow when we visualize it just like this, everything appears like one single polyline. But you can see that that one single river is made up of different polylines. Now there are ways to merge all of these together based on this river name, because we have a common river name, and we might be also doing that in a couple of steps later. But just for the time being, I just wanted to explain to you guys, even though we have two different attributes over here, by the looks of it, it's actually not the case when you open up the attributes table. These two different rivers have been made up of different river segments, which we can visually see from this attributes table, just like this. Alright, something to keep in mind, and it's always a good practice if you happen to select something just like this, before you exit the attributes table, to deselect everything, unless your intention was for some reason to select that particular attribute. Now if I come to this region of interest, open the attributes table, you can see that it actually doesn't contain anything much. We have the mandatory column over here which explains the type of the shapefile, which is a polygon. And we have something called just ID, which actually doesn't say much about the region of interest. And if I go to this region of interest 2, it's similar to the region of interest 2. And this region of interest 1, the attributes are actually quite similar in terms of the structure to region of interest 2. Just that when I select this one, you can see that this region of interest 1 gets selected. Alright, I'm going to close this one out. Alright, now I'm going to talk about different methods of styling vector data and adding labels, which can be extremely useful when you are working with vector data. Alright, now you can remember in the attributes table of this banks shapefile, we got to see some names of different banks. But let's say if I wanted to quickly get an idea about this particular point, as you see over here, and let's say I wanted to know what this bank could be without opening the attributes table. Now when using ArcMap, one of the most commonly used tools to access information from the attributes table very quickly but without opening the attributes table is simply by using this identify tool. All you have to do is click on the item or click on the attribute for which you would like to obtain the information. So for example, if I want to know information about this particular point, you can see that the same things that we saw inside the attributes table now gets displayed, but only for this particular point because you clicked on that. And from here we can very easily see that this is Lloyd's Bank. And if I wanted to, let's say, select this particular point, you can see that that particular bank is HSBC. Now if you happen to click somewhere else, you can see that it selects something else, isn't it? In this case, I thought that I was clicking on this point, but I happened to click just a bit outside the point, which made me select this particular polygon over here. And you can narrow that down simply by selecting which layer you would like to select when you actually click on that particular item. Now if I select that, I want to select only the banks layer. And then if I click over here, and you see that nothing happens because there aren't any banks over here, but only if I happen to select the bank, yeah, now you can see that it's working. This is HSBC Bank over here, and similarly over here it's NatWest, and this bank is, yeah, it's another NatWest over here. And similarly, if I wanted to select, let's say, this polyline, I'm going to select river first, and then I can select on that particular segment. As you can recall, it's actually not just a single continuous polyline. That's why the thing that flashes right over here is actually just the piece of this segment. And the name of that river is River Tough. As you can see from here, if I select this, you can see that the name of the river along with other information is just River Eli. So instead of clicking on each of these items one by one, what if I could actually pull up some labels based on the information given on this attributes table? If I were to open these banks over here again, the attributes table of the banks, you can see that each of these attributes contain its name. Now what if I can tap into this particular column and display it on ArcMap itself? That would be quite helpful, isn't it? So what I'm going to do is just keep in mind that the name of these banks are stored under this name column. So I'm going to deselect everything. And what I'm going to do is I'm going to right click over here and go to properties. And under these properties, you have one tab called labels. So what I'm going to do is I'm going to click on these labels and select, put the tick mark for this label features in this layer. And after that, over here, I'm going to select label the different features based on the name column, as you can recall, because the name column is the one which contains the names of the different banks. And if I click on apply, you can see that now it communicates with the attributes table and it sort of pulls out the name of the bank just like this. And if you click OK, now you can very easily zoom in and see which bank each of these points refer to. Quite interesting, isn't it? You can do the same thing with polylines and polygons as well. And if you wanted to do some changes to the font size and the font style, you can simply do that by going to properties again. And from here, you can see that you have most of the common editing tools which you can see in a standard word processing software, like making the text bold, or you can select a different text from here. I'm going to stick with Arial, and maybe I will increase the font size just a little bit. I can even italic the font if I want. And after doing all of that, just click OK, apply, and you can click OK. And now you can see that the name is quite apparent over here. You can see over here it's the Lloyds Bank, HSBC, NatWest, Barclays over here. Along with this, if you would like to make some changes to these different attributes, you can do that as well. Let's say for these points, if you would like to increase the size of the points, or if you would like to maybe put a different icon for these points, you can simply do that by clicking on this particular icon that you see over here. Now in this case, the existing icon for banks is just a dot like this. Now if I were to click on this dot, you can see that it opens up a symbol selector. From here you can increase the size of the dot just like this if you wish to, or if you would like to select a different icon from here. Let's say I wanted to select this circle 7 icon and maybe change the color to be red, decrease the size just a bit, and if I click OK, you can see that now the banks got appeared with a different icon. Looks a bit like messy with all the labels. So to turn off the labels, you can simply just untick this one, and if you click apply, you can see that the labels actually got disappeared. Since we're talking about the styling of vector data, of course, just like points, you can style your other types of vector data as well. For example, if you wanted to change the style of your rivers, what I'm going to do is I'm going to click on this icon over here, which will open up the symbol selector. And from here, the first thing that I'm going to do is maybe change the line color to be a bit of a darker blue. And I'm going to increase the width maybe to about 1.7. And after that, I can click OK. Yeah, now you can see that the river line did thicken a bit, just like this. And now if I wanted to make a change to my region of interest to polygon, you can see that I can have a fill color, maybe a different fill color like this for the region of interest 2, and maybe green color for region of interest 1. Just like this, you can do some basic vector styling simply by clicking on this particular icon that you can see right below the name of the layer. Now, especially when you're talking about polygons, you might encounter certain cases where you don't really need to fill up the entire polygon with colors, but you would only like to have the outline of the polygon. Now, for example, over here, we have no idea actually how much is the extent of this region of interest 1, because this particular thing as a layer is actually below this region of interest 2. You can see that the order of the layers over here, if I were to select this region of interest, means left click, and if I drag it on top of this region of interest 2, you can see that this layer extends all the way up until here, which I couldn't see before because of this order of these layers. What I'm going to do is I'm going to put this layer back below this region of interest 2, which means this region of interest 2 will come on top of this region of interest 1. And one smart way to actually know the extent of the region of interest 1 is actually by getting rid of the fill color of this region of interest 2, and by only retaining the outline, which you can simply do by again going to this symbol selector, and from here the fill color, I'm going to select no color. But the outline, I'm going to maybe select black, and I'm going to thicken the line a bit up until maybe 2 units. And if I click OK, you can see that the fill color got removed, but instead we just have this outline. And from here we can basically get an idea about the extent of this region of interest 1. And you can simply do that for region of interest 1 as well if you wish to. You can select no color, and the outline, let's say in this case I'm going to specify the outline in this sort of an orange color. Increase the thickness a bit. Yeah, from here you can see the different spatial extents of the region of interest 1 and region of interest 2. So I hope you guys got some sort of a basic idea about styling different vector data, which you can simply do by clicking on this particular icon, which is right below that individual layer, and you can do the stylings according to your preference. Again, for example, if you wanted to style the river in a different way, you can see that there are some recommendations from Esri itself, depending on the type of the attribute. For example, for highways, you can actually use this, and for expressways, you can use these inbuilt type of stylings, but it's completely up to you to actually use those. For example, I'm going to use this to represent my river. In that case, if you were to use one of these inbuilt styles, I don't really need to go over here and worry about changing the corresponding color or changing the width. I can simply click OK after selecting this particular icon, and you can see that my rivers got changed accordingly. But of course, depending on your situation, you might need to change the colors, and you might need to make the appropriate changes to the thickness of your line depending on your specific case. Alright, that's a bit about styling your vector data and how to add labels to your different attributes. Now I'm going to go ahead and teach you some basic geoprocessing tasks. Alright, so for this exercise, I'm going to actually talk about 5 different geoprocessing tasks, which I personally happen to use very frequently. So I thought that it would be good to teach you guys these, but of course, we are not going to get ourselves limited to only these 5 geoprocessing tasks. As you learn more and more things, you will discover that depending on your specific case, you might be required to use the corresponding geoprocessing tool for your own specific case. But I'm going to get started with teaching you how to clip vector data. Now, if you would like to temporarily turn on or off these layers, you can simply do that by unchecking this box over here corresponding to each layer. You can see that if I only wanted to have the region of interest 1 and let's say banks, I can activate and deactivate the other layers accordingly. And let's say if I only wanted to have the region of interest 2 and the rivers, what I would do is I would just go ahead and uncheck these banks and this region of interest 1. Of course, there's no harm in having those in your working interface, but if you feel that it's actually kind of hindering your work with so many layers displaying different information, it's always good to actually just turn them off and focus on the layers that you're actually working with at that particular moment. So to teach you guys how to use the clip geoprocessing tool, what I'm going to do is I'm going to open up region of interest 1 and the rivers shapefile. I'm going to cut this rivers shapefile using this region of interest 1 shapefile so that I will get the corresponding stretches of these 2 rivers which falls only inside my region of interest 1. Now visually you can see that that would be something starting from here all the way up to here for this river Eli, and from here all the way up to here for this river Tough. And let's say for some reason I don't really need these stretches of the river which falls outside of my region of interest 1. And for those kind of applications, we can simply use the clip tool. Now again, you can use this arc toolbox to navigate to the place where you can get this clip tool, or the method that I prefer to use is just this search panel, and I'm going to type clip, and the tool which I'm interested in is this clip analysis tool. And you can see that if you were to click on this green color text, it opens up the exact location where the clip tool is located inside this arc toolbox. It's on analysis tools and extract and clip. So you can either double click over here, or you can directly click on this clip analysis tool, which will open up this particular window. So I'm going to get rid of this search panel for the time being, and I'm going to input the features. So my input features are going to be the river polyline. Either I can expand this and select river from here, or if you have that in the layers panel, it's also actually quite convenient to just drag it and drop it over here. Now that's actually the way that how I prefer to do it. And I'm going to clip the features using the boundary of the region of interest 1. If you can see over here, And if I were to expand this over here, you can see that we still get the region of interest 1 over here, which you can directly select. If not, you can simply drag it and drop it over here. And we can select the output feature class from here. If you open up this, you can see that we don't get to see all the folders that we would normally see if you were to use Windows Explorer, because as you can remember before, we made the connection to this specific folder. That's why we get to see only this specific folder, which actually makes the things quite clean as well. Because once you make the connection, it'll always be here, so that you don't have to start navigating from the C or D drive itself and go all the way up until the corresponding folder. So what I'm going to do is I'm going to click on this particular location. I'm going to open up these shapefiles because we are still dealing with different shapefiles. And I'm going to name this as clip_river. Maybe rivers. And click on save. And you can see that automatically the file type changes to be .shp. Alright, now we can simply click OK. And over here at the bottom, if you see a spinning globe or just a frozen globe, just like this, you can get the idea that ArcMap is actually doing some sort of a geoprocessing task. And afterwards, you will see that it automatically adds that new vector layer. In this case, it's clip_rivers. Now, it might not be that apparent because the color of this particular layer is actually something like a light green. So of course I can go ahead and click on that particular icon and maybe change that to dark blue, and maybe I can increase the width to be about 3. And now you can see that we get the stretches of the river, which corresponds to only the boundaries of this region of interest 1. Now if I were to just turn off this main rivers layer, you can see that now we have the rivers until the extent of the boundary of this region of interest 1, which can be actually quite helpful in certain different tasks. And again, if I go to this attributes table of these clip rivers, you can see that the attributes table appears like this. I'm going to double click on this name column heading just like this, and you can see that River Eli, if I were to highlight it like this, these are the different polyline segments which sort of forms this River Eli. According to this, if I were to select everything which corresponds to River Eli, you can see that the entire polyline gets selected. Well, all the pieces of the polyline get selected, and similarly the case is the same for River Taff as well. As you can see over here, I'm going to deselect everything. Now let's say that if you wanted to use this clip tool to identify something like all the banks which falls within the region of interest, let's say 2. So what you can do is you can simply turn off all the other unrequired layers. Just keep in mind that it's actually not a must to turn them off. It's just for your own visualizing purposes. It makes no difference having them turned on or off for this particular geoprocessing task. So now since I know where exactly this clip tool is located at, I'm going to go over here. Or if you were to access it from the toolbox directly, you can even open up the Arc toolbox, go to extract clip from here, double click on that, and you can get the same exact tool again. In this case, my input features are going to be banks, which are going to get clipped by the boundary of the region of interest 2, so that it will sort of only isolate the banks which are located inside this region of interest 2. And similarly, I'm going to change the output location to, well, this one I should have, the previous one I think it would have been good if I put maybe the clipped rivers of region of interest 1, but in this case I'm going to say banks region of interest 2, just to make the whole name a bit short. And after that I can click OK to run this particular clip tool. And if I turned the main banks layer off, now you can see that it actually gives me all the banks which are located only inside this region of interest 2. Now again, you can notice that whenever we do a certain geoprocessing task, the resulting layer will not actually contain all those specific layer styling which we did for this initial layer. Unfortunately, you might have to redo all the styling again every time when you do a different geoprocessing task. And it's not that different. Let's say in this case, if I wanted to use triangles to represent my banks which are located inside this region of interest 2, I can change the color like this as well. Maybe decrease the size just a bit. Yeah. And if I wanted to add the labels, you can see that I can select the name of the bank, that particular column, and maybe I can select this label features in this layer, and Maybe I can bold it out as well. Yeah, now you can see that very clearly what are the banks which are located inside this region of interest too, isn't it? Yeah. Alright, so I'm going to turn this layer off as well. And by the way, if you have a look at this Arc catalog now, you will see those two new layers which you added, banks underscore ROI2, it's over here, and the clip reverse shapefile is also over here. And if you think that a layer is not here which is supposed to be here, maybe you might be able to just refresh this particular folder simply by right clicking over here and click refresh, and then it'll sort of refresh and show you the most updated set of files that you have inside this particular folder. And even if you happen to navigate this shapefiles folder using the Windows Explorer, you can see that when we created this banks underscore ROI2, it doesn't mean that it only created this particular .shp file. It means that it created this entire set of different files which work together in order to make this shapefile a fully functional shapefile. Alright, I'm going to close this one out. So the next geoprocessing tool which I'm going to be using today is intersect tool. Now this intersect tool can be very efficiently used for identifying areas which are common to multiple shapefiles in terms of its spatial extent. Now over here you can see that this region of interest 1 over this side just belongs to the region of interest 1, and similarly this region of interest 2 over here actually belongs to the region of interest 2 only. But if you look at this common boundary over here, it belongs to the region of interest 1 as well as the region of interest 2. So what if I were to sort of only isolate this particular common part, which is actually common to region of interest 1 and 2 both? We can use the intersect tool to very efficiently mark out those common areas. So again, I can open up the search panel and type intersect, and over here you can see that we get this intersect analysis tool. Well, from now on I think I will directly use this search panel to open up the tools, but in case if you are curious to know where this tool is exactly located at, you can click on this green color path, which will sort of open up the exact address to that particular tool over here. But for our convenience, I'm just going to actually use the tools from now on directly from the search panel. So what I need over here is this intersect analysis tool. I'm going to open this one up directly. And after that, I will specify my input features. Now over here, for the intersection to happen, I have two input features, of which the first is the region of interest 1, and then I also have the region of interest 2. So these are the two layers which will sort of get blended together, and it'll extract only the spatial areas which are actually common to both of these different layers. And again, I'm going to specify the output to be region of interest common like this, and I will save that, and I'm going to leave the other settings as default, and I can simply click OK. And now you can see that it created a new shapefile which is of type polygon, of course, and it created that particular shapefile to highlight this common area of interest. Now if I were to deselect this and turn these two layers off, you can see that we have a very precise cut of this common area, just like this. Now this kind of information can be useful, especially let's say if I were to now visualize all the banks which are located inside this common area. You can see that these are the different banks which are actually located inside this common area. And let's say if you wanted to calculate the area in square meters or square kilometers, it's actually quite convenient to first create this shapefile which corresponds to this common area, and then later on do the calculation of the area, which we will also be discussing just in a few minutes. Alright, I'm going to turn this one off and this banks layer off as well. Now I'm going to talk about the union geoprocessing tool. Now from the intersect tool, we saw that we got the common area by intersecting two layers. But what if you wanted to get one particular shapefile for this entire study area by sort of blending these two together? Now that can be quite easily done by the union tool. I'm going to use this union analysis tool, and similar to what we did before, I'm going to drag these two layers over here, select the corresponding path. I'm going to say region of interest union, and if I click OK, you will see that now it generates one single shapefile which includes all these attributes together. Now if I were to turn these two off, you can see that it's just one single shapefile, but now it's made up of three different attributes. The part which is unique to region of interest 1, the part which is unique to region of interest 2, and the common part of region of interest 1 and region of interest 2. Now these intersect and union tools are actually quite similar to the Venn diagrams in probability. Just as a side note, if you have any experience on that, as you can see on the screen, let's say if you have two circles called A and B, the part which corresponds to the intersection will be actually this middle part because it contains items from both A and B. But if we were to talk about union, that means we're actually talking about this entire A and B circles, because that includes everything, including the items which are unique to A and items which are unique to B, as well as the items which are common to A and B. So it's basically the same principle, but over here we're applying that for geospatial data. Alright, so the fourth vector geoprocessing tool which I'm going to discuss with you guys today is the dissolve tool. Now I'm going to use this the original reverse layer in order to explain the application of the dissolve tool. Now, as you can recall, if we were to consider, let's say, this river Tuff, you can see that the river is actually made out of different segments, just like this. Well, let me go ahead and change the color to be a bit of a darker blue so that whenever I highlight some part, you will be able to see quite clearly. Yeah, just like this. Whenever you want to sort of merge attributes based on a common name, you can do that using the dissolve tool. Now, for example, let's say I don't want to have different pieces of line segments like this. I want to actually have just one continuous line segment. By merging all of these pieces together, we can simply do that for the river over here. And we can merge all of these pieces of line attributes over here based on this common name, which is this river Eli, using this dissolve tool. So what I'm going to do is I'm going to, let's say dissolve. I'm going to select this dissolve data management tool. And from here, I'm going to drag this river shapefile and drop it over here. And as soon as you do that, you will see that, well, let me first go ahead and set the path to be reverse dissolve. And as soon as I add the corresponding shapefile, you will see that a full list of these column headings right over here. So it's asking us based on what particular field I would like to perform this dissolve operation. In this case, I would like to merge all the attributes which have the same river name. So what I'm going to do is I'm going to select this name over here so that it'll actually sort of dissolve all of these attributes together to create one single attribute which contains that particular river name. Alright, so I'm going to click OK, and you can see that the tool is running. And now you can see that we got a new shapefile over here already, which is reverse dissolve. If I change maybe the color to make it a bit more visually apparent, you can see that it's basically the same exact shapefile visually as what it was before. Over here, if I turn this one off, you can see that the underlying river layer appears. And if I turn this one on, you can see that it basically covers the same exact extent. But what's different over here is in the attributes table, you can see that now the different pieces of polylines of river Eli has now been merged together. The same goes for river Tuff as well. And now you can see that it's actually very handy to use this dissolve tool in so many different applications where you want to sort of merge all of these different attributes together, isn't it? So I'm going to use this dissolve tool once more for this ROI union, because let me go ahead and turn off this reverse layer. Let's say if I were to select individual pieces of ROI union, it's made out of 3 different polygon attributes just like this. But what if I wanted to merge everything together? Well, if you properly understood the concept of dissolve, by looking at this attributes table now, you might be able to think that we cannot use dissolve tool for this specific case because we don't have any common properties. Over here in the rivers, we had the name of the river as the common property. But in this case, we do not really have any common property, isn't it? Well, in such a case, what I would usually do is I would just rather create a new column and just put a random common property. Let's say if you can put number 1 for all these 3, we can dissolve it based on that because it's a common property for all these 3 different pieces of attributes. So, well, we are going to learn something new as well over here, how to add new columns to this attributes table. Go to table options, expand this and select add field. And over here, we need to give the heading. I'm going to just give a random name. Let's say we can say common property, something like that. And over here, we have to select the data type. Now, in this case, I'm going to leave the data type to be short integer because if I click OK, you can see that by default, it actually puts zeros to all these different attributes. I don't really care what the value over here is, and I don't really care whether the value over here is even a text. All I want is actually for these three different items to be the same exact value, because then I can specify this common column against which I would like to perform this dissolve operation, so that it'll sort of merge all of these three together. So again, I can go to this search panel, and since I already searched for the tool before, it's just right over here. And now I'm going to drag this ROI union and drop it over here. And in this case, well, I don't really have to select this like this. I'm just going to specify I would like to do the dissolve operation based on this common column, which is right over here. Again, I'm going to specify this one to be ROI common, maybe 2, like this. And if I click OK, you can see that now it got rid of all these individual splits in between, isn't it? And it appears as one single shapefile, which is of type polygon, and we don't have any individual splits in between. And these kind of things can be easily achieved using the dissolve tool. Alright guys, so the final basic vector geoprocessing tool that we're going to discuss for this tutorial today is the buffer tool. Now the buffer tool can actually be used, as the name explains itself, to create some sort of a buffer based on a given vector. Now what's meant by creating a buffer is basically an extension of the area starting from a specified point based on a specified distance. Now for example, if you wanted to create a buffer for this reverse dissolve, let's say if I wanted to create a separate shapefile to identify the area which corresponds to a buffer of 1000 meters beyond the left and the right river banks of this river, we can simply use the buffer tool to demarcate that kind of a thing. Now again, I'm going to use the search panel to open up this buffer tool. And it's going to be the buffer analysis tool. And from here, I'm going to specify my input feature, which is going to be this river dissolve. And I'm going to specify the distance. Let's say we wanted the buffer to be 1000 meters. We specify the unit over here first. And from here, we can specify I want the buffer to be 1000 meters. And I can also specify the location. I will say river underscore 1000 meters. And now if I click OK, you will see that it actually creates out a zone. Now this zone is of type polygon. You can check that from here. Yeah, you can see that it's actually of type polygon. And this zone creates a buffer which extends 1000 meters perpendicular to the left and the right of the river for both of these different attributes. Now if you wanted to do a quick check, we have something like this measure tool which we can use to actually check whether the buffer tool worked correctly or not. So what I'm going to do is I'm going to activate this measure tool, and over here make sure that I'm going to measure a distance in meters. And after that I can zoom in, and when you measure the distance, always make sure that you measure the distance somewhat perpendicularly to a certain stretch of a river. So let's say if I wanted to check the distance from here to up to here, it says the length is about 1016 meters. Well, that's because I'm not perfectly able to identify the exact perpendicular line. Let's say if you were to consider this to be a point, the radius of the point will be 1000 meters. That's what's meant by that. Similarly, let's say if you go over here and if you try to measure the distance, you can see that it's more or less about 1000 meters. Well, it's actually going to be 1000 meters just because I cannot do it by hand. We see a bit of an error over here, but this is how it creates the buffer of 1000 meters. Now let's say if I wanted to create a buffer for this ROI common, I can simply use that tool again, and my input feature is going to be this ROI common, and I would like to identify an area which corresponds to, let's say, 2.5 kilometers further beyond the outer edge of this polygon. I'm going to name this one as ROI common 2.5 km. Well, you should keep in mind that ArcMap actually does not allow very lengthy names. So in case if you notice that your name has been shortened by ArcMap, well, that's the reason, because your name was a bit too long. So try to keep it short. And now if I click OK, you will see that it actually creates this buffer of 2.5 kilometers. For example, if I check the distance from here up to here, you can see that it's more or less about 2550 meters. Well, that's how the buffer tool works. So I guess you guys got the basic idea of how to use these basic vector geoprocessing tools. And of course, as we do more things, we will realize that we can make use of the available hundreds of tools built into ArcGIS to our advantage to do our tasks very smoothly and efficiently if we know exactly which tool to use. And again, this is just a basic introductory tutorial, but of course, if you have been following our channel for quite some time, or if you're interested in actually checking out the other tutorial videos, you will see that we are sort of making use of quite a number of tools which are available or which are built into ArcGIS itself. So that's something to keep in mind. Alright guys, so just like that, you have reached the end of the part 1 of this tutorial, but we still have a long way to go. We've got so many things to cover, and we'll be continuing on from part 2. You can check out the link for the part 2 down in the description below. So I'll see you guys in the next one.